I am here in the exhibition of historic physics instruments at the University of Birmingham. I'm going to show you this wave machine, which was devised by Sir Charles Wheatstone. He was Professor of Experimental Philosophy at the University of London. That is what we would now call Professor of Physics. The purpose of the machine was to demonstrate the behaviour of transverse waves, such as occur in plane and circularly polarised light. This is a closer view of the machine. The machines were built by John Newman of London, and our model is marked as sold by Elliott Brothers. The machine contains an array of metal bars tipped with white balls. These bars are moved up and down or from side to side by wooden sliders, like this one. They have a wave profile on one side. In our machine, some of the original sliders are missing and have been replaced with ones made of perspex. As the sliders are pushed through the machine, they generate travelling waves on the white balls. Here on the side of the machine we have a travelling plane wave. The balls move up and down in a vertical plane, and as I push the sliders into and out of the machine, the waves appear to move back and forth. A feature of the machine is that waves are built into it in the absence of the sliders. Here we see the vertical plane wave built into the balls on the top of the machine. It has the same wavelength as the travelling wave we have just seen. I can now add to this built-in wave the travelling plane wave we have just seen, and this produces interference. When the waves are out of phase, there is no resultant, and we see a horizontal line of balls. When the waves are in phase, we see a wave of double amplitude. The travelling wave remains visible on the lower set of balls. A second set of sliders moves the bars horizontally, enabling us to combine vertically and horizontally polarised plane waves. When the waves are in phase, this produces a travelling plane wave on a plane inclined at 45 degrees to the vertical. When the horizontal and vertical waves are 90 degrees out of phase, they produce a circularly polarised travelling wave. The wave here has the form of a right-handed helix. With the opposite phase difference, we obtain a left-handed circularly polarised wave. The machine is now set up with a built-in right-handed circularly polarised wave on the top. If we add to this a travelling wave that is also right-handed, we produce interference. When the waves are out of phase, the resultant is zero, a straight line of balls. When the waves are in phase, we get a giant helix of double amplitude. When we add a left-handed circularly polarised wave to the built-in right-handed one, they produce a plane polarised wave. The remarkable thing is that the plane of polarisation now rotates as the phase difference of the two waves is changed. At the time that Wheatstone invented this demonstration, light was known to have wave properties, and because light could be polarised, the waves had to be transverse. It was several decades before Maxwell produced his theory of the electromagnetic nature of light. So this machine must have been devised to help people understand the nature of transverse waves in general. Others had produced models of travelling plane waves before this, but Wheatstone's machine was the first, and maybe the only one, to demonstrate circular polarisation and the combination of circularly polarised waves. The original full kit included extra sliders of different wavelength to allow the demonstration of further effects. Only a few machines were ever made. Ours has the serial number 31, which is the largest known number. Many of the earlier ones have been lost or broken. Wheatstone never wrote an account of the machine himself. The only instructions available at the time were 2 handwritten pages of notes by the manufacturer John Newman. A fuller account was written by P.A. Secchi in Italian in 1850, and a modern article is that by Julian Holland in Rittenhouse in 1999.